What if I told you that there's a place in the United States where the mountains are so steep that they've isolated its population for generations, or that the very mineral wealth that powered the nation's industrial rise is now destroying its own landscape, leveling entire mountaintops? Welcome to West Virginia, a state known for its wild beauty and deep mining heritage, but one whose geography is so extreme that it has held back its development for over a century. These are 8 geographic problems that make this region one of the most challenging and fragile in all of the United States. The most fundamental geographic problem facing West Virginia is not actually a mountain range in the traditional sense, but a massive ancient plateau that has been aggressively eroded into a labyrinth of steep ridges and narrow valleys. This geological feature, known as the Allegheny Plateau, covers the vast majority of the state and creates a landscape of relentless verticality. Unlike the jagged peaks of the Rocky Mountains, which often feature wide intermountain basins, the topography of West Virginia consists of a continuous succession of sharp V-shaped valleys and narrow hollows. This creates a physical environment where flat land is a precious and vanishingly rare commodity. In many counties, there is virtually no level ground for the construction of large-scale manufacturing plants, modern airports, or sprawling residential developments. This lack of buildable space has forced communities to cling to the thin strips of land along riverbanks, which in turn places them in the direct path of frequent and devastating floods. The geographic isolation caused by this terrain is difficult to overstate. Every mile of highway construction in West Virginia is an engineering nightmare involving massive cuts into mountainsides, the bridging of deep ravines, and the constant stabilization of shifting shale and sandstone. Because the terrain prevents a logical grid system for transportation, traveling between 2 towns that are only 10 miles apart as the crow flies can often take 45 minutes or more along winding, narrow 2-lane roads that follow the serpentine path of least resistance. This fragmentation of the landscape has led to a fragmented economy, where the high cost of moving goods and people acts as a permanent tax on the state's productivity. The verticality also complicates the delivery of modern infrastructure, such as high-speed internet and reliable cellular service, as the steep ridges block signals and make the installation of fiber optic cables prohibitively expensive. In a digital world, the physical geography of West Virginia acts as a barrier that keeps its residents disconnected from the global marketplace. Before we continue, subscribe so you don't miss the geographic problems that are transforming the map of the United States. While the natural erosion of the plateau took millions of years, human intervention over the last 5 decades has radically altered the geography of southern West Virginia through a process known as mountaintop removal mining. This practice involves the use of massive amounts of explosives to blast away as much as 800 to 1,000 feet of mountaintop to reach thin seams of coal buried deep within the earth. The resulting rock and debris, known as overburden, are then pushed into the adjacent valleys, creating what are called valley fills. This is not merely an environmental issue, but a profound geographic catastrophe that permanently changes the elevation and profile of the landscape. Over 500 mountains in the Appalachian region have been leveled, and thousands of miles of headwater streams have been buried under hundreds of millions of tons of rubble. The majestic, multi-layered canopy of the ancient Appalachian forest is replaced by flat, grassy plateaus that lack the ecological complexity and water-holding capacity of the original terrain. The geographic impact of these valley fills extends far beyond the mine site itself. By filling in the natural drainage patterns of the mountains, this practice alters the hydrology of the entire region. The natural sponges of the forest floor and the intricate network of mountain streams are gone, replaced by compacted surfaces that accelerate runoff during heavy rain events. This contributes to a heightened risk of flash flooding for the communities downstream, as the landscape no longer has the capacity to slow and absorb precipitation. Furthermore, the creation of these artificial plateaus does not result in usable land for the state. The soil quality is often too poor for agriculture, and the underlying rubble is frequently too unstable for heavy construction. This leaves the state with a scarred, desolate landscape that is neither a natural mountain nor a functional plain, representing a permanent loss of the state's primary geographic asset. Beneath the surface of West Virginia's rugged exterior lies a hidden geographic crisis that poisons the state's lifeblood, its water. For over a century, The extensive tunneling and excavation required for deep coal mining have exposed iron sulfide minerals, such as pyrite, to air and water. This chemical reaction creates sulfuric acid and dissolved iron, a mixture known as acid mine drainage. This toxic orange sludge seeps out of abandoned mines and into the state's extensive network of creeks and rivers. Because West Virginia's geography is defined by its watershed, with thousands of small streams feeding into major rivers like the Monongahela, the Kanawha, and the New River, the pollution from a single abandoned mine can affect ecosystems hundreds of miles downstream. The water becomes so acidic that it kills fish, insects, and aquatic plants, turning vibrant mountain streams into biological deserts. This problem is compounded by the sheer scale of historical mining. There are thousands of abandoned mines across the state, many of which were closed long before modern environmental regulations were enacted. The geography of the subsurface is a honeycomb of interconnected tunnels that can span entire counties, making it nearly impossible to map or contain the flow of contaminated water. As groundwater moves through these voids, it picks up heavy metals like aluminum, manganese, and arsenic, which eventually find their way into the drinking water supplies of rural communities. The cost of treating this water is astronomical and represents a long-term economic drain on a state that already struggles with poverty. This geographic poisoning of the well means that despite being one of the wettest states in the eastern United States, many parts of West Virginia face a chronic shortage of clean, usable water for both human consumption and industrial use. West Virginia's topography acts as a giant natural funnel system that transforms standard rain events into catastrophic flash floods with a speed and ferocity rarely seen in other parts of the world. Because the state is characterized by high, steep ridges and incredibly narrow valley floors, there is no expansive floodplain to absorb or slow the movement of water. When a heavy storm system stalls over the Appalachian Mountains, gravity pulls every drop of precipitation down the perpendicular slopes and into the constricted channels of the creeks and rivers below. This is often referred to as a flash flood because the transit time from the ridgetop to the valley floor is measured in minutes rather than hours or days. In many of the most vulnerable counties, the difference in elevation between the mountain crest and the stream bed can be over 1,000 feet within a horizontal distance of less than half a mile. This extreme gradient gives the descending water immense kinetic energy, allowing it to uproot ancient trees, move boulders the size of vehicles, and destroy any man-made structures in its path. The physical shape of the land effectively ensures that water will always be the state's most unpredictable and destructive neighbor. Furthermore, the human geography of West Virginia is inextricably linked to these dangerous valley floors. Because the surrounding ridges are too steep for development, almost all of the state's critical infrastructure, including primary highways, railway lines, schools, and residential neighborhoods, is concentrated in the narrowest part of the funnel. This creates a geographic trap where the only viable land for human habitation is also the most dangerous. During the catastrophic flooding event of June 2016, for example, several inches of rain fell in a matter of hours across the central part of the state. The resulting surge of water was unable to spread out and instead rose vertically with terrifying speed, inundating towns that were thought to be safe from historic high water marks. This recurring geographic threat makes long-term investment difficult, as the risk of losing everything to a single atmospheric event remains a constant reality for hundreds of thousands of residents. This is compounded by the orographic effect, where the mountains themselves force moist air upward, cooling it and triggering even more intense rainfall, meaning the very geography of the state creates its own localized weather patterns that favor flood conditions. The second major geographic hazard that plagues the state is the inherent instability of its sloping earth, which manifests as one of the highest rates of landslide activity in the United States. This is a direct result of the state's unique sedimentary geology combined with its steep terrain. A significant portion of the bedrock in West Virginia consists of weak shales and clays, particularly those within the Conemaugh and Monongahela geological groups. These specific rock layers, often called red beds by local geologists, are notorious for their lack of structural integrity. When these layers are exposed to the high annual precipitation levels typical of the Appalachian climate, they absorb water and transform into a slick, lubricated surface. Once the internal friction of the soil and rock is overcome by the weight of the water-saturated earth above it, gravity pulls the entire hillside downward in a slow motion or rapid onset collapse. This process is not limited to isolated incidents, but is a pervasive geographic characteristic that affects nearly every county in the state. This geographic instability is frequently exacerbated by human activities required to survive in such a vertical environment. To build roads or homes, engineers must cut into the base of these steep slopes, removing the very material that provides the mechanical support for the rest of the mountain. Even with modern retaining walls and sophisticated drainage systems, the sheer volume of moving earth often overwhelms man-made defenses. The economic cost of this geographic reality is staggering. The West Virginia Department of Transportation is forced to spend tens of millions of dollars every year simply to clear debris from highways and repair roads that have literally slid off the side of a mountain. For private homeowners, the problem is even more dire, as standard insurance policies typically do not cover damage caused by earth movement, leaving many families with worthless property and no means of recovery. The very ground that defines the beauty of the mountain state is, in many places, a fundamentally unstable foundation that refuses to remain stationary, leading to a phenomenon known as soil creep, where the entire landscape is slowly but surely migrating toward the valley floors. While much of West Virginia is defined by its solid sandstone ridges, a significant portion of the eastern and southern regions is built upon a subterranean landscape of limestone known as karst. This geography creates a Swiss cheese effect beneath the surface, where slightly acidic rainwater has, over millions of years, dissolved the bedrock to create a vast network of caves, sinkholes, and underground rivers. In areas like the Greenbrier Valley and parts of Monroe and Berkeley counties, the traditional relationship between surface water and groundwater is completely severed. Entire streams can suddenly vanish into the earth, only to reappear miles away as massive springs. While this creates a unique and beautiful landscape, it presents a profound geographic problem for modern development and environmental protection. The Great Savannah region of the state is particularly susceptible to this, where the lush rolling fields hide a chaotic and hollow world just a few dozen feet below the grass. The primary danger of karst geography is its unpredictability and its impact on infrastructure. Sinkholes can form without warning, swallowing sections of highway, farmland, or even entire buildings as the ceiling of an underground cavern finally gives way. This makes the construction of heavy infrastructure, such as natural gas pipelines or large industrial facilities, a high-risk endeavor that requires extensive and expensive geophysical surveying to ensure the ground will not collapse under its own weight. Moreover, the karst system acts as a direct pipeline for pollution. In most geographic settings, the soil acts as a natural filter that cleanses water as it percolates down into an aquifer. In a karst landscape, however, surface runoff, complete with agricultural chemicals, road salt, and industrial waste, can flow directly into an open sinkhole and enter the drinking water supply almost instantly without any filtration. This creates a scenario where a chemical spill in one location can contaminate the water of a community 30 or 40 miles away in a matter of hours, following a subterranean path that is often unmapped and poorly understood. The invisible, hollow geography of the karst regions represents a permanent challenge to the safety and stability of the state's eastern frontier, where even the disposal of household waste in a septic system becomes a potential threat to the entire region's water security. The forests of West Virginia are not merely a collection of trees, but a complex geographic system that is currently undergoing a process of systemic collapse, a phenomenon that could be described as biological erosion. This crisis is rooted in the extreme fragmentation of the landscape, which has transformed what was once a vast, unbroken sea of green into a series of disconnected biological islands. In the 19th and early 20th centuries, the state was almost entirely clear-cut to provide timber for the industrialization of the United States. And while the forests have largely grown back, the modern geography of the land is far different from its original state. Today, the landscape is crisscrossed by more than 35,000 miles of public roads and an untold number of private logging paths, utility corridors, and natural gas pipeline swaths. This fragmentation creates a profound geographic problem known as the edge effect, which alters the microclimate of the forest for hundreds of feet into the interior. Areas that were once cool, moist, and dark are now exposed to increased sunlight and wind, which dries out the forest floor and changes the composition of the vegetation. This geographic opening of the forest canopy has facilitated the rapid and devastating spread of invasive species that are physically restructuring the landscape. The hemlock woolly adelgid, an aphid-like insect from Asia, has moved through the state's mountain corridors with alarming speed, killing the eastern hemlock trees that are vital to the geographic stability of mountain watersheds. These trees serve as the primary anchors for the soil along steep-walled ravines, and as they die, the physical geography of these valleys begins to unravel. Without the deep, interlocking root systems of the hemlocks, the thin mountain soils are easily washed away by the state's frequent heavy rains, leading to increased siltation in the river systems and a permanent loss of the land's structural integrity. Similarly, the emerald ash borer has decimated the ash population, which was a critical component of the state's hardwood forests. The loss of these billions of trees is not just an ecological tragedy, but a geographic one, as it changes the way water moves across the surface of the land, increases the risk of landslides, and removes the natural barriers that once protected the soil from the elements. This biological erosion is further complicated by the legacy of atmospheric deposition, where the geography of the mountains traps pollutants from industrial centers to the west, leading to acid rain that leaches essential nutrients like calcium and magnesium from the thin, high-altitude soils. The geographic shredding of the forest by natural gas pipelines further exacerbates this issue, as these corridors act as conduits for invasive plants like Japanese stiltgrass and multiflora rose, which displace native ground cover and further weaken the soil's resistance to erosion. This chemical and biological degradation of the soil geography has caused a significant decline in the growth of the red spruce forests along the Allegheny front, which are the highest and most remote ecosystems in the state. As these unique geographic zones weaken, they become even more vulnerable to the encroaching warmth of a changing climate, representing a slow-motion collapse of the state's most iconic and protective natural feature. The cumulative result of these biological pressures is a landscape that is physically less stable and less resilient than it was a century ago, creating a feedback loop where the degradation of the forest makes the state increasingly susceptible to the other geographic hazards of flooding and land instability. Remember to subscribe to stay up to date with the geography of the United States. The single most significant geographic problem facing West Virginia, and the one that ultimately explains its long-term economic and social struggles, is the topographic entrapment of its population and infrastructure. This is a condition where the physical shape of the Earth acts as a permanent barrier to the kind of expansion and connectivity required for a modern, diversified economy. Unlike the surrounding states of Ohio, Pennsylvania, or Virginia, which possess large areas of relatively flat or gently rolling land, suitable for urban sprawl and large-scale industrialization, West Virginia is defined by a relentless and aggressive verticality. The state has the highest mean elevation of any state east of the Mississippi River, but more importantly, it lacks the broad valleys and plains that traditionally serve as the centers of human civilization. This geographic reality has forced the state into a pattern of development that is uniquely inefficient and vulnerable. Because there is virtually no level ground for the construction of modern cities, the state's major urban centers are compressed into the narrowest parts of the river valleys. This topographic compression means that land prices in the tiny pockets of buildable space are often artificially high, while the vast majority of the state's land area is too steep for any use other than timbering or mining. This is the geographic trap. The land that is flat enough to build on is also the land that is most susceptible to the catastrophic flooding described earlier, while the land that is safe from flooding is too steep to build on. This physical constraint prevents the formation of agglomeration economies, where businesses and people cluster together to share resources and ideas. In West Virginia, the geography forces separation. The state's infrastructure is a testament to this geographic burden. Every mile of interstate highway in West Virginia costs significantly more to build and maintain than in almost any other state, because the terrain requires a constant cycle of blasting through mountains and bridging deep chasms. The state's primary east-west corridor, Interstate 64, must climb thousands of feet over multiple mountain ridges, placing a physical limit on the speed and efficiency of transportation and trade. This topographic isolation is not merely a matter of convenience. It is a fundamental economic disadvantage that discourages the entry of new industries. A company looking to build a large-scale data center or an automobile assembly plant requires hundreds of acres of contiguous flat land with easy access to transportation hubs, a geographic combination that simply does not exist in most of West Virginia. This forces the state to remain dependent on a few specific industries, like coal and natural gas extraction, which are able to operate in rugged terrain but do not provide the broad-based economic stability of a diversified urban economy. This entrapment also creates a geographic drain, where the physical difficulty of the terrain contributes to the outmigration of the population toward more accessible landscapes. The lack of centrality means there is no true cultural or economic heart to the state, leading to a fragmented identity. As the world becomes increasingly urbanized and interconnected, the physical geography of West Virginia acts as a cage, trapping its residents in an 18th century landscape while the rest of the country moves into the 21st. This is the ultimate geographic problem. The very mountains that provide the state with its identity and beauty are also the walls that prevent it from achieving long-term prosperity and stability, leaving West Virginia as a geographic outlier in the heart of the eastern United States. What do you think of these 8 geographical problems about the state of West Virginia?